These are the rest of our notes for today. We're actually going to go in the back first. I feel like it'd be easier to do the examples and then talk about the characteristics of them. So go ahead and create your box plot. So you're going to need your 5 numbers. So go ahead and find your min, your Q1, median, Q3, and max. So the first example is in order for you. If you want to jump down to the next example, this one's not in order. So go ahead and do the box plot for example 1 and for example number 2. Okay, so for example number 1, you should have got your min is 2, your Q1 is 4, median is 5, Q3 is 7, max is 10. We check to see if there's any outliers, so your lower fence is negative 0.5. There's nothing lower than that. And our upper fence is 11.5. There's nothing higher, so we have no outliers. So we did a dot on 2, a line on 4, a line on 5, a line on 7, and a dot on 10. Connected the box and connected the whiskers. Okay, for example number 2, it took a little bit longer, so we went ahead and put the numbers in order. We got our min is 2, Q1 is 4, median is 6, Q3 is 7.5, max is 11. So we checked our lower fence and our upper fence. We had nothing lower than this, nothing higher, so we had no outliers. We went ahead and drew a line, or a dot, a line, 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 and a dot. So then we connected our box and connected our whiskers. So hopefully that was okay for you. Now we're going to move on to the dot plot. So dot plots are super easy. So we're going to use the same exact number line. So go ahead and number it the same exact way you did for your box plot. Now what you're going to do is in its name, you're just going to draw dots over all the numbers. So we're going to go exactly how we see it. You can go in order or out of order. It doesn't matter. So we just put 1 dot above 2 because we only had 1, 2. 1 dot above 3. 2 dots above 4. 4 dots above 5. 1 over 6. 2 over 7. 1 over 8. Nothing on 9. And 1 on 10. And that's all you do for dot plots. So go ahead and do the dot plot for the next one. So you can do it out of order or in order. It does not matter. So go ahead and do that. This is what you should have got for your dot plot. Now, when we have data that's super out of order, it's actually super easy to do the dot plot first because then you'd put 1 dot over 2, 1 dot over 3, 2 dots over 4 until you get all of your numbers. Then you can actually go back, then write it in order because this tells me I should have 2 2s. Tells me I have 1 3, tells me I had 5 4s. So to make sure you actually don't skip a number, you can just go ahead and make a dot plot first, and then it puts your data in order. Now the very last type of statistical graphs that we have is called a histogram. So the very first thing is we actually need a frequency chart. So frequency is just how often does it occur. So we have these things called intervals. And then we're going to have these things that we're going to be filling up, and they're called bins. So we're basically going to create a bin. We're going to fill it up with a certain amount of numbers. So now to find a bin size, easiest way to do it is we're going to take our range, and we always want at least 5. We might have more, but for today we're only going to stick with 5 bins. So my range for example number 1 is that we're going to take the max minus the min, which is 8. When we divide that, we actually get 1.6. Now you don't want a bin size that's a decimal, so we're going to round it up to 2. So that's saying we want 2 numbers in our intervals. So this is what it means. So my lowest number, my min is 2. So we're going to say my 2 and the interval is going to go to 3. The reason why it's saying that is that 1 is one number and 3 is the next number. So we actually have 2 numbers that are in this interval. The next one is going to go to 4 and then 5. So 4 and 5 are 2 numbers. Then 6 to 7 are 2 numbers. 8 to to 9 are 2, and 10 to 11. So my bin size are holding 2 numbers. So now the easiest way is to look at our dot plot. Okay, the next thing we do is we're going to figure out how many numbers is inside of this. So we're going to look at our dot plot. So how many numbers is either a 2 or a 3 or in between 2 and 3? So we got 1, 2, and 1, 3. So we're going to say 2 numbers fall in that bin. And then we're going to say 4 and 5 is going to have 6 numbers. So if you look at 4, there's 2, and then 5 has 4. So in total is 6. From 6 to 7 is 3. 8 to 9 is 1, and 10 to 11 is 1. So you have to complete the frequency chart first before you do the histogram. Now the first thing on the histogram is that we're going to do the intervals on the bottom. We have 2 to 3, 4 to 5, 6 to 7, 8 to 9, and 10 to 11. So those are our intervals, and this is our frequency, so our highest number is 6. So we're going to go 1, 2, 3, 4, 5, and then 6. Now, these are telling our bar heights. So from 2 to 3, we had 2 numbers, so we're going to go from here and draw down. So 2 to 3. 4 to 5 is 6, so we're going to connect it and go up to 6. So if you notice, there are no gaps. 6 to 7 is 3. 8 to 9 is 1. And 10 to 11 is 1. So there are no gaps. The reason why there are no gaps is that the data is one after another. So there's nothing that's left behind because 3 and 4, so 4 comes directly after 3, so everything's connected. So I'm going to go ahead and give you the bins. So we're going to calculate the bin size first on the next one. So again, we're going to take the range divided by 5 in this case. So our range is 11 minus 2, which is 9 over 2, or 9 over 5, which is 1.8. So again, we round it up to 2. So our bin size is 2. So we're going to have the same exact bins as these are. So we're going to 2 to 3, so that holds 2 numbers. 4 to 5, 6 to 7, 8 to 9, and 10 to 11. So go ahead and see how many numbers fit in these, and go ahead and complete your histogram. Okay, so your histogram should look like this. We had 3, 5, 7, 3, and 2. We actually had to extend our frequency y-axis by 1. And your histogram should look something like this. So we notice majority of your data is in the middle, and we'll talk a lot more tomorrow about that. So we have our 3 types. We have our box plot, our dot plot, and our histogram. Now we're actually going to go back to the front. We're going to talk about the characteristics of all the graphs. So the very first thing is that we're going to say what kind of data do all of these display. So we're going to write quantitative, okay, versus categorical. These sound really complicated. Okay, so quantitative and categorical. Now, the one that probably sounds familiar to you, or you could probably dissect, is categorical, because it sounds like categories. Well, you're right. So this deals with data with categories. And quantitative is data with numbers. So just numbers. So the only ones that are categorical are like bar graphs and pie charts. So this is a type of bar graph. So we know that they are not connected. They have gaps in between. And our categories are rabbit, dog, cat, goldfish, and hamster. So we don't have a number line on the bottom. So that's why this is called a categorical data. Okay, as a spoiler though, if you notice, all of the things that we've been dealing with have been on number lines, so all of these are actually going to be the other one, which is called quantitative. So all these display quantitative data. So I'm just writing quantitative in every single blank. Okay, Okay, so going back up to the box plot, so we know it's quantitative data because it's on a number line. So the advantages of the box plot is that it sums up all our data into just 5 points. So we got the minimum, Q1, median, Q3, max. It's very easily, we can compare 2 or more. So we can actually have one on top of another. So we can say like which one has the highest median, which one has the lowest median, and all the good stuff. And this also handles extremely large data sets. So we could actually have like 500 numbers in this data set and we would not know because it simply goes down to 5 numbers. Now that's also one of its downfalls. One of them is that it's not very appealing to look at. And the other one is that you can't account for the exact values. So the exact values are not retained. So in this case, individual data is lost. So we have no idea if they had 20 numbers to make this dot plot or box and whisker plot. We have no idea if there was 500. So that's the only thing. Now moving on to dot plots though, so we know that it's quantitative data because it's on a number line. This is extremely easy to make. So when we did our other ones, we just drew a number line and did all the dots that fit. Now this one, it says it shows each individual data point. So I know exactly how many 1.5 or halves, ones, 1.5, and so on. Now, disadvantages is that if you had like 500 data points, you don't want to do a dot plot. So it can be very time consuming with tons of data. And the other one is fractions are pretty hard to display. So in this case, we do see halves. But if I want to put like 0.7, you have no idea where that dot would go because it might be further closer to 0.6 or 0.5. So fractions are really hard to display. And our last one is a histogram. So of course, we know it's quantitative data because it's numbers. It's very visually strong. So it's pretty cool to see all the data and see the shape that it makes. So tomorrow, so it's very good to determine the shape. And this is again going to be a tomorrow thing. But the disadvantages is, again, you cannot read exact values. So the individual data is lost again. So if we look at this bin right here, so it's 100 to 110, we have no clue how many 108s there were, 105s. We just know that there was roughly 27 datas in this bin. So because there is an interval though, we have no exact values. And the last one, it's very hard to compare the two data sets because you might have different bins, you might have different frequencies and all that. So this is the end of the notes for today.